coming. I hope you are learning with these lectures. Before starting for today, there is an important announcement. Today, in the means after the session, there will be a Google form will be shared. So you have to fill the details very carefully. That Google form is for your certificate preparation. Enter your details, your name, your means affiliation correctly and very carefully. The name which you will type will be there in the certificate. Okay. And we'll be checking attendance also for certificate. 80% attendance should be there for means you have to attend thorough lecture. Meanwhile, if there are any feedbacks are welcome. Sushil sir,
Yes.
Professor Subramaniam sir is not here.
No,
We are
no. He
waiting
will
for him.
join. He will join. I call him. He is
Yes,
ready
sir.
to join.
Okay.
Just wait for a
Okay.
minute.
Okay. 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 Sure.
क्या
Yeah, good afternoon, everybody. Yeah,
Good
Sushil.
afternoon, sir.
Good
Good
afternoon,
afternoon,
sir.
sir.
So we
So,
have Professor. Yes.
okay,
Sorry,
start.
you are not audible. Well, I'm audible to you.
Yes, sir, you are.
Yes, sir, you are ready. Okay.
So we have Professor RBP Subramaniam with us. Yesterday he was not available due to some health issues. Somebody has said a teacher's heart heals a little more with every lesson taught and every mind inspired. So I hope today he'll recover soon by delivering the lecture for the whole day. Isn't it, sir?
Yeah, now it is audible. Fine.
Yes. Yes. So sir will be taking lecture in the first half, and after the break also sir will continue.
Okay, thank you.
Yeah.
Yeah, I'm
Yes.
Subramaniam.
Uh, Wait, sir. I'll introduce you first. Yes, sir. I'm pleased to introduce him as a esteemed speaker for our today's FDP. Professor R.B.V. Subramaniam is Distinguished Professor in the Department of Computer Science and Engineering at National Institute of Technology, Warangal. He holds an MTech and a PhD from IIT Kharagpur and made significant contributions to the field of data mining, big data analytics, distributed data mining, graph databases, and soft computing. He also served as a chief investigator of the Electronics and ICT Academy and has played a pivotal role in encouraging research and innovation. He has also been actively involved in organizing numerous workshops and conferences on cutting edge technologies, including big data and machine learning. With a strong academic and research background, Professor Subramaniam has mentored several PhD scholars, authored numerous high impact publications, and collaborated on various government funded projects. His work bridges the gap between theory and practice, making him a guiding force for both researchers and educators. We are truly privileged to have him with us today to share his insight and expertise. Let's extend a warm welcome to Professor R.B.V. Subramanian. Sir. Yes, sir, you can start now.
Yeah, thank you, Dr. Iraja Heer,
Hira.
for introducing me. Thank you for your kind words. Yeah. Yes, this FDPs have been organized by Electronics and ICT Academy already, perhaps in the inauguration session. We are aware that there are 6 other academies in India, all are contributing to improve the quality of the faculty in the sense that the young faculty will be exposure to the teaching methodologies and who have some of the courses perhaps research oriented. It may motivate some of the people who would like to migrate to those new areas. And there may be teachers who have been teaching or better than us. But here the purpose is to deliver the lecture as we teach in our classes. So something if it is good, can take it from these lectures. Fine. Topic that is given to me to cover the next 4 hours is introducing this machine learning and then the classification problem, discuss certain approaches to to solve the problem. But it was supposed yesterday it was scheduled, but by this time already certain topics have been covered. As you are aware that this AI, machine learning, deep learning, data science, these are all becoming buzzwords currently, where the goal of AI is to design the agents. The agents which will have thinking ability. Hence, they want to adopt an agent which can think, but how we can adopt the thinking ability? Since we know how we think, hence the initial goal was design the agents who can think like humans. Then human thinking is also evolving. You may be thinking better than me, then whose thinking is to be taken as the ideal. Hence why I say your thinking may be better. As per your thinking, if learning and the knowledge what you gain, the decisions what you take to perform certain tasks, is better than me, we say your thinking is better. Again, better means the resources what you use, the way you use it, the way you take the decision may be optimal. Hence, the ultimate goal of this thinking process, whether you adopt Mr. X or Mr. Y or Miss Y, Miss Z, it is optimal. Hence, at all possible places, try to prove it is optimal or not. Hence, the agents which can think optimally was the next goal. If it's beyond human thinking, better you design the agents which can think optimally. Once we have that thinking ability, then we can learn. And we learn to acquire the knowledge. Knowledge is required to perform the task. Hence, we gain the knowledge to perform several tasks. I'm teaching. Teaching is a task. For that, I need knowledge. Driving. Hence, human beings have been doing tasks right from morning. Okay. Every human being, whether young or old, everyone do certain tasks. Hence, by learning, we get the knowledge. The knowledge is useful for performing the task. Hence, how do you perform the task? Hence, performing tasks, again, it can be like human, or you may perform often. Hence, either perform or act, you have to ultimately do it in optimal manner. Hence, the ultimate goal of AI is let agents think optimally and act optimally or perform the task optimally. Because when it's required to perform, okay, I want to carry this duster and carry up to here, move and then put it there. I need the hand kind of thing. I want to move means I must have legs. Hence, it may be human way of doing it. That's what. To perform the task, we require something else, not only the thinking ability. Hence, we need to have this kind. Hence, for that, people initially thought that, okay, let agents also perform like humans. That's why the many robots, they have similar to us, like the robots have hands and legs and they move like us. But you can go beyond it. It need not be only human way of performing tasks. Hence, in some other way also, if you can perform tasks in a better manner, optimally, that is in fact the ultimate goal. Hence, the AI, the goal is designing agents which can think optimally, act optimally. And when we focus only on the thinking, which I have said that it is required for learning, that part is focused in the mission learning. Hence here we want to make the missions to learn. Here we want to make the missions to learn. Hence, as I have already indicated that, how I can make the missions to learn. Hence, missions also have to start learning like humans. Hence, I have to provide the human way of learning abilities to the mission so that mission also become knowledgeable. Hence, this is what the beginning. Then, to provide such a learning ability to the mission, we have to review or think back how we started learning in our lives. Because we want to make the missions to learn like humans. And then, if possible, prove it optimal or you can go towards the optimal way of learning. Hence, we learn about the objects in some domain where you want to perform the task. Hence, right from our childhood, we have been exposed to several objects. Hence, several objects were introduced to us. Thereby, we got acquaintance with that or knowledge about those objects. Then we know how to handle them, then how to perform the task using them. These are all the ways that we have started our lives. Hence, if you recollect, you perhaps, your parents, particularly your mother, perhaps introduced several objects in your home that perhaps your first learning. She might have introduced taking an object. The object may be a fruit or a vegetable in the home, and you will be asked to look at the shape of the fruit and taste and color. These are all which we call them as the features. Hence, the fruits and vegetables have the features, where one fruit and one vegetable differ with the other. Hence, one fruit may have some shape, it may have some taste, it may be of red color, and so on. But there is another object, it differs with this. It may also be red, but it may have different taste, different shape. And these objects are introduced to you so that you will distinguish them from the values of the features. Since the values of the features are differing, you will recognize those objects are distinct. And some of the objects perhaps already labeled. Hence, one fruit may be already labeled as apple. Another, this vegetable may be tomato. You should know those labels, which we call them class labels. For the reason, then all others are calling that fruit as an apple. You should also call it with the same name. You can't give your own name. That's why these objects which are already labeled, in addition to observing the feature values, it is essential to note down what is that label already given. Hence, this is how she starts introducing the objects. The next one may be green, it may be chili, another one again red, it may be carrot, something like that. When she introduced these objects, then further many others in your family and then teachers, friends, you have got exposed to several objects surrounding you. Thereby, you have learned about the labeled objects. But of course, every object is not labeled, hence there are other objects that are unlabeled objects. When you move from labeled to unlabeled, the unlabeled labeled object also has values for the features. The only difference is that unlabeled object do not have any class label. Hence, sometimes you can learn on your own, whereas if it is a labeled object, someone has to tell the name of that object that others are referring with, calling with. Hence, the labeled object we may require a supervisor. Hence, we are learning with the help of a supervisor. Hence, this is called supervisor learning. Okay. And for unlabeled object, don't you require supervisor? Mostly not necessary, since it is not labeled. Hence, you can have a different kind of learning called unsupervised learning. This is how perhaps topics were introduced yesterday and day before. Here I have reviewed for the reason. This way, human beings got introduced to so many objects. And this I want to call it as the data. More particularly with the name, training. Because your mother has trained you in recognizing vegetables and fruits. కొంచెం పక్కగా ఉంది.
ఒకసారి కనుక్కోరు సార్
కొంచెం ఇక్కడే కొంచెం.
Yes, okay. Now it is visible.
Fine.
Wait. Okay. Okay. Thank you, sir.
Yes. Hence here, since you are learning when someone else is introducing it, this part I want to call it as a training that we have received from your mother and others. Okay. Now you may ask, no sir, my mother never wrote like this on the board in the form of table. Maybe a different board. Maybe she was speaking, you were able to listen, see. Hence we have listening ability, seeing abilities. But I can't expect my vision to see or listen. Okay. And in the interaction between you and your mother, perhaps she was speaking with you, asking a child, you see the shape of this fruit is like this, if you want you can taste it, is it not the taste even? Observe the color. Hence in between such words are there, but similar words she is using for the other object. But if you filter out those common words, where when you move from one object to another object, what are the changes? The changes are, when she was speaking, the changes are occurring only in the shape value, taste value. Hence, from that audio or that verbal kind of conversation, whatever that, you can extract the values of these features and you can figure out she is teaching you, training you through certain features. Whereas other words are only helping you to understand that. Those are all common words. Hence that variation, that variance we catch and we figure out what they represent. One may be representing shape, another value may be representing taste, and we will note down this. Hence we may be, hence it is not wrong to say that this kind of table can be formulated from such communication, such conversation. Or even if I give you a text, from the text you can extract the values of the features and then you can prepare like this. Hence, what was the initial form? Whether was it a conversation between two human beings or are you extracting this from the text by processing it? Ultimately, this is most convenient way of representing. Hence now, this I will give it as an input to the mission. Now from this mission, from this data, training data, the mission has to learn. Okay. Now it is data, you are aware that. Why it is data? This red is a color. Hence, the apple fruit having red color is a fact. Hence, its shape is a fact. Its taste is a fact. Hence, the definition what you might have noted from other courses, that data is collection of facts. Yes, here what I have noted is S1, P1, Z, these are all. Their values of the features are nothing but data. Hence, mission has to learn only from this data. Mission has to learn only from this kind of data. Yes, that's why data is crucial. We are not expecting mission to learn in any other way. But now, compared to the earlier days where these algorithms are being developed, now the advent of technology is making the mission to sense itself. What is the color, what is the taste, what is the shape. Hence it is able to extract these features by observing or by sensing. Hence if the mission has those sensing abilities, hence perhaps it is noting down those values. But ultimately, without loss of generality, I can think that those are all being captured and placed in this format. Is it not? Hence, ultimately, you have this training data. Hence, how you obtained it, maybe through the mission sensors or some other human being is giving you this training data, or someone has given the text form, you have extracted it, whatever it may be. Ultimately, you have this tabular kind. Now, what we can do? Hence, I said that the missions ultimately we learn to perform the task. When it comes to the task, which I have said, the teaching, learning, driving, cooking, all these tasks you observe yourself. Your first day of cooking and today of cooking. Your first day driving and today teaching. And many of these tasks, if I measure how good you are performing it, if someone measures this measured value will increase as you gain more and more experience. Hence you will feel that, oh, after a few years, yes, I have started 5 years back, now I am able to drive very good. Hence there is a lot of improvement in performing that particular task of driving with experience. Hence, if I ask you about experience, you may be telling that, yes, sir, I have 5 years experience or 20 years experience, 15 years experience, something like that. Is that experience always 15 years, 20 years? And when you are expecting mission to perform the task, do you want to say that let my mission also get to 15 years experience, then only it will perform the task better? Otherwise, if you look at the books, they write this kind of definition that mission starts learning to perform the task in better and better manner as they gain more and more experience, and it picks up how to learn on its own. These are all being covered in the definition. Hence here in the name of experience, do you expect that, sir, now only my mission started, it's now few hours only, that it also gets 5 years experience, then it will perform better. No, that's not the way that you have interpreted the word experience. You take two doctors, a doctor in a rural area, and he gets one patient per week, only one patient per week. I'm referring one of the doctor, not every doctor in the rural area. Hence, some doctor who is receiving only one patient per week, the patient also has leisure time. He will sit before the doctor for any number of hours. And slowly that patient explains his problems, and the doctor will start diagnosing. Thus, he gained 20 years experience. You can imagine how many distinct patients, distinct diseases, perhaps that doctor treated. Whereas you take another doctor, either in the same area or in city, where you have one patient for every 15 minutes. He also gained 20 years experience. Do you want to say that both have 20 years experience, same experience? You say that the doctor in the city is more experienced because he has seen more patients and more diseases he has treated. Hence he is more experienced. Though the span of time that both have served is 20 years. Hence, in the name of experience, what it matters, the number of patients, the number of objects that you are, from which you are learning. Hence, here also when I say more and more experience, it is not this years, rather the number of objects. Hence, here you see this data. I am giving one tuple, one row for each object. Hence, when I want to accommodate more and more objects, when I want to learn more and more objects, during training period I should have sufficiently, this training data I sufficiently have large number of objects. Hence, if you learn from huge amount of data, then particularly covering all samples and all different classes, is apple is a class, tomato is another class, chili is another class, C4, and maybe another kind of tomato, maybe which is something yellow kind. Fine. Look at all the variations. It's again C2. It's not necessarily one sample for each class, whether there are several objects belong to the same class. Thus, you are exposed to several classes, maybe C1, C2, Cm, maybe 20,000 fruits and vegetables. Fine. Hence, to perform the task, to make the learning more complete, you should learn from possibly huge amount of data covering possibly maximum number of classes and all the samples indicating whether we are giving the variations from one kind of object, one kind of the object to another kind of object belonging to the same classes. That's why we insist that the data must be used. Otherwise, if you learn from less amount of data, will not that knowledge complete. Then this is slightly different. Hence, initially we take this as the point. Hence, let us take huge amount of data and then start learning from it. Okay. Right. Now, what for we are learning from this training data? What task that we can do? The task may be, you are given an object. Once the training is over, the object is given here, the given object, where its features are all given, like it was in the training data. The difference between the training time and now is the training time your mother used to tell the class label, but now in the testing, you have to specify the class. You have to specify the class. Hence, you have to specify the class to which the x belongs to, which the x belongs to. That's what I want to call simply specify the class of x. And this particular thing I can simply call the task is classify x. Is this task what we call classifying the objects that can be performed if you learn something from this training data. Is the task we take now is to classify the objects, classify the x, classify y. As I am going on showing an object, you are specifying the classes, hence you are classifying the objects. With all the knowledge which we have received during the training period, this is the task that we want to consider now. Fine. Hence, this I would like to formulate as a classification problem. Hence, what you can write formally, given the training data, it means what? Training data will contain the feature value, features, and each object will have feature values. In addition to the feature values, there is something called the class label. We have sufficiently large number of objects given, covering all the variations, samples of the objects belonging to certain number of classes, which may be noted as C1, C2, Cm. Not necessarily happen like this. You can just visualize and you can represent with the symbol C1, C2, Cm. And these features you can represent with F1, F2, F3, and Fn. N number of features. For example, I have written space, taste, color, and apple number. Hence, you can replace. If you move to another training data, there will be yet another set of features, there will be some other classes, the objects, values of the features. Hence, given such a training data, you have to learn and classify the given objects. That's the task. This is the task. Now, you are performing this task because you got exposure to these objects and fruits. And that's why I have taken this example, because you have experienced this in your life. Now, your objective is to make the mission to classify X the way you classify. Hence, mission has to learn from this training data, like you have learned from your mother. Hence, for that, which you have to design now some approach and then algorithm, then you can code it. This is what you have to do now. Okay, fine. Yes, for this, you have to recollect how you have learned, and the same thing that you can put it here. As it is not new to you, this particular task, I expect some of you to tell how you have learned and what is that? Is that the way you have learned? Do you think that is possible for the mission also to do? Of course, from this training data. Okay. Hence, the question is how to learn from this training data. What you want to learn from this training data. How to learn, what to learn, so that you can perform the task. This you have to tell. Maybe one or two participants may interact with me, telling me how to learn from this training data or what to learn. If you do not get any idea, at least tell me why you can't learn. Why you are unable to learn from this if you cannot learn. If you can learn, okay, tell me how you want to learn. If you cannot learn, tell me the reason why you can't learn here. Why you are unable to learn from this training data? Either that question or this question. Maybe one or two participants may interact. Anyone? Maybe first question is tough, how to learn, what to learn. At least second question, I think you can tell me. Why you can't learn? What is the difficulty? Why you are unable to learn? What do you think, sir? This is the reason, this may be the reason I am feeling difficult in learning. This kind of difficulty I never faced while I was learning from my mother. Okay, you compare that with this data and that training. What is difficulty in learning from this data compared to the learning what we have already done during your training time from your mother? Hope my question is clear. Anyone interested to speak?
Yes, sir. I'm Sridhar. I would like to answer this. The thing is, depending on the cognitive level, I feel the things which were made easier, whereas here, whenever the new things which has to be studied with respect to theoretical aspects, where we need to remember or something like that, which you are not seen in the virtual, which has to be seen, which has to be studied in the virtual manner, would make us difficult.
Okay. What is virtual manner here? I am writing everything on the board. The data is given to you explicitly. You are able to see. In the same way, the machine also has this data in its memory. Physically, the data is available. It can access, it can read, it can learn from that data. Now the question is, what is that difficulty that you face? Sridhar, can you just repeat certain words or something valuable? Can you repeat it once again?
Sridhar, sir.
What you want to figure out?
Sorry, sir?
No, why you want to figure out that, what is that you want to say? The difficulty in learning from this kind of data. You have said something, no? Can you repeat it so that I will get a little bit out of it?
So we can see the objects clearly. I mean, whereas to make it understand, it requires a lot of efforts. I mean, a lot of input data that has to be given, which is not required on the other hand. That's what I personally feel.
You require more data or you don't require? What do you say?
We require more data.
Fine, I have provided. Of course, I can't write everything. I might have given, see, I can't write it everything on the board, but you assume that I have given 3 million objects. 3 million objects.
Yes, sir.
Their data values for various features and their class labels. Class labels also nearly covering some 1,000 classes. I have given sufficiently. You can assume that, oh, such a huge data is provided to a mission to you. Then, how to learn, what to learn? One question. if that question cannot be answered, at least you have to answer another question. What I said, that why you can't learn? What is difficulty that you see here? Why you are unable to learn? Any other participant? Some of you perhaps teaching. Some of you have studied this course. Oh, is it all are new? Since Mr. Sridhar tried to tell that there is difficulty in this data set. This difficulty was not there. But what is the difficulty? He is unable to properly put. But he noticed there is difficulty. That difficulty he did not face when he was learning from his mother. His mother was a good teacher, taught several fruits and vegetables. That's why he knows. She did not confuse. There was no confusion, there was no ambiguity arise during her teaching. Because every mother likes to teach her son or daughter in the best possible way. Hence, there was no such ambiguity, confusion. Hence, is it not? That's why afterwards we compare teachers with your first teacher and the next high school level teachers you compare with your elementary school level teachers and so on. You say this teacher, oh, most confusing things. Oh, it's confusing. Lot of confusion is arising. His talk is ambiguous. Ambiguity is there in her talk or his talk. It's like this we comment some teachers and we label them as poor teachers. Because the way I teach may have a lot of ambiguity. I will be creating confusion. Hence, my talk may lack the clarity. Hence, when confusion is there, why that confusion is happening? You recollect when that confusion arises, when that ambiguity arises, particularly when you are looking at or listening to a teacher whom you call, who brand as good, whom you branded as good. He may not be really good. He is also delivering the content properly. But the way he is delivering, you don't like, you have called him poor teacher. Because there's a lot of ambiguity, there's confusion. Then if you figure out the reason, oh, the teacher gives, but the question is he will jump from one concept to the other and again he will come back. Oh, he will mix up these topics. He won't teach the topics in the logical order. These are all the reasons you will tell why you have branded him, why the confusion is arising in the class. He's delivering content, but the question is he's mixing up this and that. Instead of mixing up, if he teaches in some order, things would have been different. Otherwise, content is beautiful. This is how you will write your comments. Is it not? Hence, the reasons for this confusion, ambiguity, that what you are attributing, that he is mixing up the concepts. Do you consider, is there any such reason here? Is this a mixer? you look at this data. Hence, if I ask you, come on, describe the data, I don't want to repeat. I don't want to repeat that there are objects, sir, and objects have values for the features, they are all labeled. These are all already told. That is not the one what I want. But you may find that, oh, this is the mixture of objects whose data is given, but it is a mixture of objects belonging to various classes. Hence, objects belonging to various classes are given in a mixed form. Hence, this data is a mixture of objects belonging to various classes. Someone has started thinking in that way. Hence, he has noted this. Oh, this is what happened in my life. My mother only told these things, if not in this tabular form, maybe in words. But ultimately, the same thing what I am representing here. But when I look this, when I want to make my mission to learn, I'm not getting any idea how to train my mission to learn from this. I'm not getting any idea. Oh, what is the reason? Oh, it is a mixture of objects. He started that way thinking. And he succeeded. That's why I'm starting with that observation that this training data is a mixture of objects belonging to various classes. For that matter, many problems in machine learning are to be considered as mixers. The mixture of objects belonging to various things. When you have such a mixer, you have to understand what kind of mixer. Hence, in the higher level, when you are doing research, you will come across, oh, this is a Gaussian mixer, this is that mixer, this mixer, and how to do this. Hence, mostly we figure out the given problem is a mixer problem. Okay. Hence, I am starting with that word, the mixer. Hence, being it is a mixer, whenever things are mixed up, naturally this ambiguity, this confusion will arise, which stand as an obstacle, and that's why you are unable to learn. That's why you are unable to learn. Okay, let us believe this statement. Hence, let us support his observation. Okay, perhaps the mixture is the reason why the learning is not possible. So, why we feel difficult in learning from a mixer? Okay, it is a mixer. Let us agree with that. Yes, we also agree this is a mixer, no doubt. So what? It is a mixer, fine. Is it difficult to learn from mixer? Why it is difficult? This we have to put now. These questions we have to start answer. Hence, what is that characteristic of the mixer which you are attributing, standing as an obstacle in the learning process? Hence, now that we have to figure out. Hence, what is that mixer? Why you are unable to get any idea when you look at the mixer? When you look at the mixer, why you are not getting any idea to learn? Why you are unable to learn? Then you take up certain things and mix up and prepare mixer. You take milk, you take water. Now, if you mix up, you will get some liquid. It is a mixture. When I mix up milk and water, I got a mixture. Now you observe, what is the problem with this mixture? The problem with the mixture is, it has got impurity, which was not present earlier. As such, milk was pure, as such, water was pure, but when you mix up the liquid, which is a mixture, is suffering from impurity. Suffering from impurity, which you don't like. You don't like impurity that a mixture is suffering from. Okay. That's why now always we have issues with your friends. You will say, oh, their thinking is very impure. Hence you don't like impurity in your friends' thinking, in your family members' thinking. You don't want impurity anywhere. Oh, the air is lot of impurities there. Hence, every aspect, every substance, right from morning, you are looking at, oh, these are all impure, which you don't like. Is it not? Hence, a mixture always suffers from impurity. That impurity, the very characteristic of the mixture, which is impurity, the mixture which is suffering from impurity, that is the real reason why you are unable to learn. So what to do? Okay, you have diagnosed and ultimately rooted, finally, oh, impurity in the mixture is causing a difficulty in learning. Okay, you have figured out. So what to do now? Okay, mixture is suffering from impurity. Now what to do? Okay, there's a lot of pollution is there. Hence this impurity, yes, it is there because it is mixed up. Several other particles mixing up, hence causing impure air and so on. Hence, when you have impurity in this mixture, what to do? Then you think, why impurity corrupted? Why impurities arise? It is because you have mixed. You have mixed milk with water. Now, can you take this liquid and demix it? If you demix and get again back the water and milk, yes, if you can demix it, can you gain purity? Will this impurity be reduced? Oh, looks good. Idea looks good. But of course, we have to think of the experiment, how to demix this liquid so that we gain milk and water, which are pure substances, back. There may be some process. Maybe you are putting it on the stove and the water gets evaporates, your milk is gone. The evaporated water, you collect it, condense the milk, get water. I don't know. There may be some process will be there. We need not bother about what is that. But idea looks good. Hence, whenever you have mixture that has impurity, the way to handle that is demix it. Hence, this approach, the process, what they have suggested Since by mixing up you got this impurity, there is hope that the demixing will reduce this impurity. Is it not? This is what we are doing. Whenever we have this impurity, we are trying to demix it and separate those things, substances which are causing impurity, we are separating them. Hence that demixing process that they could able to catch. Hence now this long discussion, you felt that is it really machine learning or something, what is this talking? Hence ultimately now you have looked that this is a mixer, this training data is a mixer, and now you want to demix it. Hence demix this D is a mixer, this D is a mixer, and you want to take that D, this training data D, and you want to demix it. Hence you want to demix this data set. Hence how you can demix it? Hence they started thinking, oh, demixing may be hopeful. Okay, good. Let us strengthen this approach. How we can demix it? That's what they have looked at. Okay, equivalent, you take an example. Okay, this data set I can figure out something like your father went to a local market with a bag and he purchased apples, tomatoes, chili, carrot and all. Unlike you bring in packets, if you go to the local market where the farmers are directly selling, okay, the apples are poured into the bag, tomato, chilies. Hence, he brought such a bag, which is a mixture of apples, tomatoes, chilies, the way in the olden days people bring from the local markets. Hence, once such a bag is brought from that, now you pour those objects onto the floor and you ask someone in the home, child, hey, come on, demix it, segregate them. Hence, the segregation process, the child starts doing. Hence, I'm asking, how do you segregate this? How do you demix this? I think this question, many of you can answer. Can someone tell how you can demix it, this data D? You have these features and classes, objects, feature values. Many things are there on the board. The data contains all these things. Now, how you will demix it?
Based on the features, sir.
Okay. Why you are thinking that feature can be taken? Why not? Suppose you call some child, won't she pick up all the apples, put it aside, the tomatoes, pick it up, and chilies? Can't she do that way? If some other participant says that, I will do that way, sir. All apples will be, pick up and put it in one cover. Then all tomatoes are taken out of that pile, and then all the chilies are identified and taken out and put it in the packet. Is not that way you demix it? No, what will be your answer? Suppose some other participant says that. How do you justify your feature-based demixing?
If it is separately taken, then there is no mixture at all. So first we
No,
need to
no,
mix and then.
no, no. I have a mixer now. My father brought in the mixer farm, and I have poured the objects on the floor. Even after pouring on the floor, also it is in the mixer form. What I want to do is demix it. Now my demixing is natural. No, I will pick up all the apples and put it in one cover. You pick up all the tomatoes and put it another cover. Chilies, you put it as a separate group. Whether you put in the cover or not, put all the chilies aside and carrots aside. No, like that. Is it not demixing process?
Yes, sir.
And if our participant says this as a teacher, no, you have to justify your thinking. What is your thinking? You want to demix it on features. How do you justify?
Uh, if it is a human, I think they can be demixed based on the class itself. But if it has to be through a machine, then I think it has to be through shape or the what are the features that has been listed.
Why? Why the machine and the human being are different? We want to see that no difference. No, I am making the mission to learn like human and become human way of classifying. That is the objective with which we have started. If that difference you want to maintain it, no time in future, mission will learn like human. Then every time you want human being to do, not replacing human beings in performing this kind of tasks. That's not the objective. Hence, if some other participant says that, okay, you pick up all apples means you know apples. You know which is tomato, which is chili, which is carrot, which is apple. Means you are already have that knowledge. My mission is yet to get that. My mission is yet to get. Don't know which is apple, which is tomato. Hence, I have to call a child, not the child who already learned apples, tomatoes, chilies, was already trained. No, no. You call much younger child. Who don't know which is apple, which is tomato, which is chili. That younger child is yet to be trained with the classes of the fruits, vegetables. You call that. But that child can see the color. As you said, the human being, they can see the color, they can taste it, they can shape, they can observe the shape. Is based on those features, segregating is possible even for the child or the mission who is not yet learned about the classes. If you have already learned about the classes, then directly you have the knowledge, you can classify it. But now my mission just now started it. My child is yet to know that. Is therefore, I want to demix on the feature. Say for example, on color. His child decides, okay, I'm able to see different colors. Okay, let me segregate on color. Hence, first object is red color. Okay, it will put in separately. Let me call, this was originally D, now the red color object is put separately as a D1. The next also red, that is also placed here. Hence object 1 is placed, object 2 is placed. That I am referring as D1. Hence in D1 only object 1, object 2 is put. The next object 3, if you look at, that is green. Oh, green, a different color. Therefore, you put it in a different group, a D2. Then again red, you put in D1. The next object, the fifth object, is yellow, put separately to start yet another group, D3. Okay. Hence, as you go down, you may get another color, yet another color, maybe blue. Okay, D4. Hence, you may have certain number of colors that are written as values under this particular feature color in this. Suppose let us assume only 4 colors are there. Hence now every other object will fall into one of these 4. No sir, not 4. Generally my father brings 10 colors. Okay, 10 colors. Somewhere some finite number, fine. Hence then the objects, whatever that number may be, 3 million or whatever it may be in the original D, they got segregated into D1, D2, D3, D4 based on the color values. Okay. I don't think that anyone has doubt how mission can see the color red, green. No, mission need not see. Mission need not have the vision. Like you are seeing red color, green color, yellow. Mission need not have that much cognizance. It may not distinguish red color from that. Whereas when you said color, it is looking at this particular feature. There is something symbol RED. This RED is red to you. You may be reading it as red, and you can figure out what do you mean by red color. You have in your mind, you know what is red color, how it is different from green. These things you know, but mission need not have that much cognizance. It's as simply noted RED. It has noted RED is a value. The next again same value RED, fine, put that. The next is green, oh different value. It is looking at this red green as values only. Fine. It is figuring out. Thus, these objects got segregated into D1, D2, D3, D4. You take any 2 groups, they are mutually disjoint. There is no common object between any 2 Di and Dj, I not equal to j. And if you perform union of D1, D2, D3, D4, you will get back the D. Hence you have segregated. Fine. Now the question is D1 a mixer? Is D1 a mixer? Mr. Sridhar, is D1 a mixer? Oh, I am troubling you since you are the only person who is responding. Is D1 a mixer? You can figure out. In D1 we have apple, we have tomato. Hence it is a mixer. When we call something as a mixer, if it contains objects belonging to more than one class. If there is a group of objects belonging to more than one class. Yes, one is tomato, another is apple. 2 different classes. Therefore, it is a mixer. Whenever you see a mixer, what we have to do, what was our decision? Whenever you see a mixer, you segregate on feature. If this is what, in fact, Sridhar suggested, he mix on the features. But tomorrow some other student may ask, that's why you should have the reason why you are not segregating on the class rather on the feature. That's why I've asked that question. Otherwise, what he said is correct. Is now next I am segregating on shape on another feature because already I have used the color feature. It's originally there are F1, F2, so on, Fn. I have taken F3 over. Now I am taking F1, which is shape. Since on the shape, I will segregate further this D1 into D11, D12, D13. Hence, based on the shape values, maybe S1, S3, and S4. There is no S2, perhaps. What do we have to do? There is no S2 shape. S2 shape may be there in the original D, but it is not there in D1. All red colored objects, none of the red colored objects are of S2 shape. It's S1, S3, S4. Now, once again, this D11, if it is a mixer, you segregate it on another feature, maybe F4. Then again, you segregate it on F2 test. T1, T5. Further again, hence how long this demixing? See, on demixing on one feature, you have got something like a tree, which is moving from root to the first level, then to another level, then at another level. Hence, each time you demix on a feature, the tree is growing level by level. How many levels you will see at the most along any path from the root? That's the question. How many levels you will have? How long you will continue this? Hence, you cannot continue more than the number of features because you are consuming one feature at a time. F3 is used, F1 is used, F4 is used, F3 is used. How many levels means as many as the number of features. If you have n features, as you going on using one by one, you will have only n levels. Afterwards, what should happen? Afterwards, the leaf levels should be come. Hence, leaf should be attached. We expect leaves if all the features are exhausted. That is, suppose your n is 5. N is 5. Only F1, F2, F3, F4, F5. Hence, F3 I have used F1, F4, F2, and suppose F5. Now, all the 5 are used. All the features are exhausted is the maximum number of internal nodes possible. Then you must get the leaf nodes. This is what expected. Is it not? Okay, now you think of how a D1 looks like. You have formulated D1 from D by placing all red colored objects. How D1 looks like? You know how D looks like? I have given. This is the way that D is looking like. How D1 looks like? How D2, D3, how D11, D12, how something which I suppose here I say D prime and D double prime, how a D prime looks like, how a D double prime looks like. Just think of another 2 minutes. Let me take some 3 minutes break. Meantime, think of it. Okay. Now let us start how D1 looks like. D1 is formulated from this D. Therefore, D is subdata set of D in the sense it will have the same number of features. I am writing same F1, F2, so on, F5 because my N is 5. F3, F4, F5. And there will be class. The first object is placed because it is red color with all its values, S1, T1, red, and so on. It is apple, everything is written. Hence, this first object is placed here. Second is also placed. Third is not placed in this. Therefore, third is placed in D2. This D2 will also be of this format only. But O3 is not placed in D2. Then again O4 is placed here, not O5. The next object will be, if at all, if you see any other red object, that will be placed in this. But notice, all these objects have same values for color, that is red, red, red. The shapes may be different, taste may be different, but color is same. Classes also may be different. One is apple, another is tomato, yet another is carrot, perhaps. Hence, if you look at this particular D1, they are same in color, but of course they may have different shapes, different tastes, different classes. That is D1. If there are different classes, you have considered it as a mixer. More than one class is a mixer. Yes, you have seen apple, tomato, carrot, the mixer. Therefore, we have separated on shape. Hence, how D11 looks. Now, when you go to D11, there in addition to the color, shape is also same for the objects placed in D1. Hence, D11 is the objects having same color red, same shape. Yes. Further, it is segregated on F4, maybe tick and into and double tick. And then further test T1, T5, F5 value, one is alpha, another is theta. Hence, how a D prime looks like. Hence, it is further D1 subset, D11, D11 subset, another D111, 112, 113, 113 further and go on. Finally, D prime and D double prime. D prime and D double prime. Hence, now I am asking how a D prime looks like. Now, D prime, if I focus on D prime. Now, D prime will have these 5 features, as I said, F1, F2, F3, F4, F5, which are shape, taste, color, so on. What about their color? Red. Hence, all the objects will have same color red, same shape S1, same F4 value, double tick. Same taste T5, same F5 value. F5 value is alpha. And therefore, you look at if the first object has this S1, T5, R, double tick, and alpha, second object is also having same feature vector. Hence, these objects in D prime, this D prime we look at, objects have same features. Same features meaning the values of the features is same for all the objects. Hence, you take any object, same features in this D prime. Is it not? Yes or no? Now, in addition, you might have noticed that the first one is C7, first object is C7, the second object also C7, and so on. Since all the objects belong to C7. This is one observation. Second observation, all the objects belong to same class. This is second observation. Since all objects have same features, all objects belong to same class. These are the two observations that we have done in this deep dive. Then in that case, since all the objects belong to same class, all are C7, then you can write C7. What is wrong? You can write here in this leaf node, write C7. Hence, what we have to do, what we have to write in leaf node is very simple. Note down that class to which all the objects belong to. Any doubt? Now, let us look at the D double prime. The D double prime also will have same color red, same shape S1, same double tick, same T5 value, but instead of alpha, F5 value is theta. This is the only difference between this theta. Hence now all the objects have same features, yes. But I am asking you to think, is there any possibility? Is there any possibility? You can agree or disagree. Okay, I am telling one statement. What is the statement? Will they belong to different classes? Will they still mix? Can this be double prime? Can it be a mixer? Though they have same features, suppose there are 20 objects in this D double prime. Will it happen that 16 may be C9, sir, 2 may be C8, and 1 is C1, another one is C6? This kind of thing may arise or not? That's my question. Or do you say that no, sir, features are same, therefore they must belong to same class? Is that what you want? Is there any possibility that they do not belong to same class? All do not belong to same class. Will it arise or won't arise? This is what I am asking you to think of. Here I cannot give all the examples. Hence, is it possible? Though features are same, is there any possibility that they do not belong to same class? Though features are same, still will it be a mixture? Just think of. Or do you rule out that Hence, it may happen that though features are same, they may belong to different classes. Then what it infers? Hence, don't rule out this. It may happen. Then you are in a very funny situation that since it is a still mixer, you can't attach leaf node. You have to attach internal node only. But if you want to attach internal node, you need a feature. But only 5 features are given. All the 5 features are already used. Hence, you can't even attach an internal. That's what I said. It's a funny situation. You can neither attach internal node nor leaf node. And you can't live like this. Hence, this situation tells you that the features what we have taken is not sufficient. It's not that every data, whatever you take with some features, will it work? It may not work. Hence, if at all, if you encounter this situation, see, all features are same. However, still the mixer, or what to do? Definitely, you can't attach leaf node. And you don't have features, that's why you can't attach internal. If you have features, you would have included internal node, no? Yes, that indicates that, oh, whatever the taken features are not sufficient. Where is guarantee? You will say that with the 5 features I can classify. No, it is telling you, you can't do, you need some more features. Or you might have forgot some feature to note down the value, feature value. Hence, the features when you are extracting either from the text or from the objects or from somewhere from source, you should find all the features, all sufficient features. Moreover, you should not again take unnecessary. Hence, what is required is necessary and sufficient features. That is desirable. Because the question is whether the features what we have taken, whether all are necessary, are they sufficient? This is very fundamental question. Otherwise, the data set is pure, it's not good. Okay. Hence, here this situation indicates the features are not sufficient. And this situation will arise. Don't rule it out. Whether it comes to your mind or not, this situation arises. In that case, what you will tell? You will ask the fellow who brought that data set, go back and think of some features which you have forgotten. And he will tell, no, I can't go back and do that process again. Suppose the data is coming from some chemical factory after doing some long process for 6 months. They say, somehow we forgot, we can't repeat that experiment, that is very costly. Somehow you go ahead, don't ask it. With this data only do it. Then you will say it will be an error. They are forcing you to attach a leaf node. Because you can't include any feature, they are forcing you to attach a leaf node. Hence you will see, oh, out of 20 objects, 16 majority belong to C9. Hence you want to write C9. It is wrong. Wrong for the other 4 objects. These 4 objects, if you look at, 2 of them belong to C8, 1 C1, another is C6. Hence this is wrong for these 4, whereas it is okay for those 16 objects which belong to C. Hence 4 objects are misclassified. If you go by this tree, because it's looking like a tree structure, which is deciding the class label for the objects. That's why this tree is called the decision tree. Hence, what we have discussed the approach is building a decision tree. Yes, if you go by this decision tree, these 4 objects will also be classified as C9. But if you look at the original data set, or this D double prime, which is a subset of that, that is telling 2 of them are C8, one is C1, the other is C6. Hence, we are attaching leaf nodes in 2 different contexts. One is you have all the features same and all belong to same class. Now, in this, all belong to same class is more important to note. Oh, all belong to same class, hence C7 is noted. Now, the question is, since they belong to same features, is that reason why they belong to same class? No, you cannot connect the observation 1 with observation 2. That observation 1 always indicates observation 2. That already now we have seen. Though features are same, it was not, did not belong to same class. Hence now you have this experience. I will figure out in D prime. If I call this as observation 1, this is observation 2, that they belong to same, they have same feature. Yes, they have same features. Do they belong to same class? Yes, they belong to same class. This is there for D prime. Whereas for D double prime, the features are same, but they do not belong to same class. These are the 2 things that we have noted as far as observation 1 and observation. Observation 1 is all the objects have same features. Second observation is all the objects belong to same class. Both are true in case of D prime. Hence you could able to write C7. Whereas in case of D double prime, it is only the features are same, but not the class. That is also noted. But however, we were forced to do, hence I have attached leaf node. I have already explained that context. Now you see D1. This D1, what is D1? Whether all features are same? No. Only one feature is same. Only color is same. Therefore, not all features same. Do they belong to same class? No. That is also there. D1. D1. This is D1. Here you see D1. Only one feature is same. Not all features are same. Do they belong to same class? No. Multiple classes. No. Apple is there, tomato is there, carrot is there. It's a mixer, multiple classes. That's why we have written mixer. D1. Now only one possibility that is left over here is, what is that? This is into, this is a tick. Will it be possible? Will this be possible or not? Will this be possible? Can someone think on this? Though features are not same, if all the objects do not have same features, means some features are different, some features are same. Yet, is there any possibility that they all belong to same class? Is that possibility arises or not? This fourth. Just have seen now both tick and into. Now into tick, is it possible? Will you have?
I don't think so, sir.
Yeah, Sridhar.
I don't think so, because if the class is same, features cannot be different.
Pictures, no? No, can you repeat?
If the class is same, then it cannot have different features.
class is same, they promote different things. Not that the negation of this is not that all the features are different. Some features are same, some features are different. That's the negation of this first statement, observation. All the objects have same features. I want to take this into means some features are same, some features are different. Not all features are same. Yes, this into you take the meaning that not all features are same. Not all features are same. Yet, do they belong to same class? You don't think so, no? Okay, one day, your father from the market, in the market there are many green vegetables. There are many green vegetables. But on one day, he did not bring any other green vegetable other than chili. Since in that particular data set, if the object is green, it is chili, because there is no other green object in that data set. Hence, if it is green object, you place it D2. Green object, you place it in D2. Green object, you place it in D2. Finally, you see the D2, which is having same color, green, 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 green. If you look at their classes also, oh, chili, chili, chili. Because in that data set, as I said to you, that on one day it so happened, the only green vegetable that he has brought, that is chili. No other green vegetable from the market he brought. There are in the market, but he did not bring. Hence, when data set is like that, and when you are learning only from that data set, actually, you are learning only whatever is there in this data set. You are not seeing anything outside the data set. The mission has to learn what is there in this data set. Now we are learning from D. Hence, in that case, they all belong to same class. Therefore, I say they all belong to same class C3. Hence, D2 is an example where not all features same. Only one feature is same. Color is same. All other perhaps same. But yet they belong to same class. This may happen like this, or maybe here also it may happen, or it may happen here. Means for the objects, 4 features are same, but not necessarily the 5th one, but they all belong to same class. Here, 2 features are same, other 3 features may not be same, yet they may belong to they may belong to some C11. This may be something C4. Hence, these leaf nodes not necessarily arise after 5th level. They may be attached at any level. They may be attached after the 1st level, or after the 2nd level, or at any level. As and when you see, they belong to same class. Hence, your observation is to attach leaf nodes. The important observation what we have to make is, do they belong to same class? If they belong to same class, attach leaf. If they do not belong to same class, multiple classes, it is a mixer, then you deal with it. Same class, attach. Different classes, demix.
Sir,
Yes.
Sir, we can have a break if you want some rest
I took 3 minutes break.
because
Fine, I will give 5 minutes break. No issue.
5 minutes break.
Yes.
Okay, okay. Generally 5 to 15,
Right. Okay, 10 minutes.
5:15 is our break time.
Right. Okay. By 15 we start.
Yes. Okay, at 5:15 we'll start. Sure, sir. So let's take a short break of around 8 to 9 minutes. So we'll start at 5:15 again.
We start. Okay. Hence, the discussion so far, we have made it clear that we have taken a mixer problem. We started demixing all features. After demixing, you will get a certain subdata sets. Each may be a mixer or non-mixer. In case it is non-mixer, you attach leaf flow. If it's a mixer, demix it further on another feature. Like this, you can continue this as long as you have the features in the hand. Hence, at some stage, all the features will be exhausted. Hence, here I have used all the 5 features. 5 features. Hence, all the features are exhausted. In between, as and when and I see non-mixer. Non-mixer I am attaching the float, no issue. But once all the features are used, one may be very clear case that it is after I may get the non-mixer. If I get mixer, there is an issue indicating that the party have taken not permitted.
कहाँ फाइनल हुई सब पूछा किसने जॉब कर दिया
Majority.
व्हाट्सएप ग्रुप बना तो
That
दिया
is
कौन बताएगा मुझे
आपको ऐड भी कर दिया
unite.
अरे मैडम तुम्हें कौन रह गया हैं ये तो बैठ तो गई है ये कौन है क्या है
फोन करना बनता है कि नहीं?
तो अभी अभी तो सामने से चढ़ी हुई है
हम इधर देख रहे हैं। अबे जल्दी आ जा भाई, बस चल पड़ी यार।
चलो चलो
आप कौन आपकी तारीख
फोन करवाना तुम। हेलो,
अरे चल यार अब किसकी इंतजार कर रहा है चल गाड़ी लेके
आ जा आ जा। अरे भाई
आप कौन है ये बताएं पहले सोशल मीडिया तो बैठो आप यहाँ पे इतनी देर नहीं
mic
रुक
is
पाएगी,
on.
सर।
Yes, your mic is on.
किसकी नहीं रोकनी है
सर वो क्या देने गया?
अरे यार है कौन
राहुल
कौन राहुल
राहुल चौहान।
आपने पूछा किससे बस में आने के लिए
हेलो,
Ritesh, Mr. Ritesh, your mic is
2
on.
मिनट का टाइम है आ रहा है तो बताओ नहीं तो चल रहे हम
Ritesh,
Can we remove him? Yeah, fine. Hence, if it is a non-mixer attached leaf node, mixer means demix all feature. Once all the features are used, if you get non-mixer attached leaf node, in case of mixer, you are not supposed to, but since you don't have features, you have to attach leaf node going by majority. This is the discussion that we have taken up. Hence, this we can say it is an approach. Once this approach is clear to you, you have any doubt? Once the approach is, I say, almost complete, once approach is ready, you should be in a position to write the algorithm. Is it not? Yes, now, whatever the approach we discussed so far, I will code it. The approach, if you code it, it will become an algorithm, that's all. Approach you may write in English, otherwise you can code it in the form of algorithm. Now I am going to code it in the form of algorithm. Since I am given a data set D having some features F1, F2, so on, Fn, there are classes. The classes are C1, C2, Cm. And we know the classification problem is learn from this and classify X. This is the problem of classification. Hence, initially I am given a data set D. I have the set of features. Since all these features I want to call it as capital F. Hence, I am taking those features set as F1, F2, F3. This is my input. And after taking it, we started discussing how to learn, what to learn, since we could not get an idea. We have attributed that it is being a mixer. I can't learn. Okay, then you start demixing it. the demixing started by creating a node and segregating on color. This is what we have done. Hence, what we have done is we have created a node. Okay, new node. Every time you create a new node. So, you have created a node. You want to segregate because it is a mixer. Then you see, once you decide to segregate on some feature, then next question is how many branches emanate from it. One question is on which being, is it a mixer or not? Yes. So on which feature you want to demix? Okay. Say color. Then how many branches emanate? The number of colors you have in this data set D. Okay. There are 4 colors, 4 branches, 10 colors, 10 branches. Then you will get D1, D2, D3, D4 kind. Each may be a mixer. If at all, if it is a mixer, further you segregate. If it is a non-mixer, you will attach it. If it is a mixer, you are selecting node and then demix. Hence, which node, which feature, heavy shape, how many branches, is it a mixer, which node, which feature, how many branches. These 2 questions are repeating. Therefore, the algorithm what you are designing will be a recursive algorithm, because your same 2 questions will be repeating means you will be writing something and calling itself. Hence, it is a recursive algorithm, Bayesian tree construction. Okay, hence I have created. Now, when you are recursively calling, sometimes that recursive call will stop on reaching some condition. When you are stopping it, see, whenever all the objects belong to same class, that is non-mixer case, you are stopping, no more demixing process. Hence, you are attaching leaf node if all the objects in the given data set belong to same class. Say CK. This may happen at any time. It may happen at the very beginning. All may belong to same class. Or it may happen at the first level or second level. At any level it may happen. Since this is one stopping condition. That is where is a non-mixer means you return this newly created label which I have given temporary name N. Return N labeled with whatever that class, because you are attaching leaf node, that leaf node should be filled with that CK, whatever that C3, something like that.
ऐसे कौन पढ़ाता है वैसे भी?
Hence, if you do not enter, hence when you are entering here, in case non-mixer, you are coming down means it is a mixer. Coming down without entering into this, if you are coming out, means this condition failed. It means not all the objects belong to same class.
पढ़ा क्या पता अच्छा ही रहा
Multiple classes. Therefore, it is a mixer. In case of mixer, I am supposed to demix it. But we have seen one exception case, that is D double prime. The D double prime, which will happen, it is, you have observed that it is still a mixture, but unfortunately, no more features. First we have used color, then F will be, from F we remove F3, then I may use the shape, then I may use something like this. I am slowly using one by one. At some stage, this capital F, as I am going on removing one after the other, the capital F will become empty, indicating all the features are used, all the features are exhausted. Hence, the deep double prime we have looked at, it is still a mixture where we are supposed to attach internal node, but we can't because no more features available. Yes, that situation also forcing us to attach a leaf node. That is what the case. Though it is a mixer, is F empty? In case F empty, attach leaf node. In case non-empty, F is non-empty and mixer. Then in that case, you select one of the features from F and you segregate on that label L with yes. That is what we have done at the beginning. We have taken at the beginning, you have seen this is a mixer. Therefore, we have selected one feature. Yes, what is that? Yes, color, and we have labeled that, and then we have segregated. Since now let us complete this particular if statement. What is this if? It's a mixer, F is empty. In this case, we have to return L labeled with what we have done in this D double prime case. I told you that there is a mixer. I said there are 20 objects, 16 are something, some C9 and 2 or 1, something, some other classes. Hence, the majority belong to C9, hence go by majority, we have attached the C9. Is it not? Hence, that let us write it here, saying that return N labeled with a class to which a majority of the tuples, of the objects belong to. If majority of the objects belong to C9, that C9 should be the label for this young. It's like this, there are two contexts where we attach leaf node. One is the clear case, all the objects belong to same class, that may happen at any stage. Or at the last stage, that is after using all the features, still if you have a mixer, you can't select the feature, no more feature, that is also foreseen. These are the two cases. If you are not of these cases, means you don't have non-mixer case, you have some features, therefore we are selecting some feature like color, shape, something we are selecting, and we are labeling N with S, and remove that F, that S from F, because we have used it, hence it should not be part of your capital. Hence you are updating the F. Okay, any doubt? Hence what we have done, you have taken one node N and it is a mixer, therefore you have selected one of the feature, color. Now what next we have done? What next we have done? After labeling L with S, Okay. After labeling L with S and removing S from the feature list, okay, this is now the segregation should start. That is, the question is, how many branches will emanate from it? It is as many values that this color has. It may have one value red, another value green, and so on. How many values? That you should know first. That's why I'm asking first the list the values. List the values of S in D. What is S? Something like your color, which you have selected. One of the features which you have selected, that I have named it as S. Hence that S, which may be color or shape or taste, it will have certain values. Those values I am asking you to list it. That list I call it as L. Hence in our example case, your L may be something like red, green, yellow, blue. These are the four values. I may call V1, V2, V3, V4. Example may be red, green kind of thing. Okay, got it? Now, for each value, that is for value 1, that is red, you have to formulate D1. For value 2, you have to formulate D2. Value 3, D3, and so on. Therefore, for each of the values, for I is equal to 1 to cardinality of L, you are forming a DI. I is equal to 1, 2, 3, so on. How many? As many values as this L has. That is cardinality of L. Okay. Hence, how you will formulate DI? How you got D1? You have taken the objects from D and put it in D1, which have red color. Therefore, DI is formed with, form DI with objects from D having Vi as value. Vi, what is Vi? I is equal to 1, V1. V1 means red in your example. Hence, Vi as value. Vi as value of S, of color. Thus, D1 is formulated. Once I is equal to 1, D1 is formulated. F is updated. F is updated. Now call this program recursively with updated F and this DA. That's what we have continued with D1. What you do? Again, you create a node, check whether it is a non-mixer. Otherwise, with mixer means if you have features selected and so on. This will recursively be done. Since that's all, since recursively will continue and program will be closed, algorithm is end. It has two exits. As and when you see a non-mixer, or once the features are exhausted, though it is a mixer, you will go by the method. These two are exist. The stopping condition where the recursive call will be stopped, otherwise this recursive call will continue. Thus you can have a decision tree built from the data set. Any doubt? Algorithm is just I have coded whatever we were talking. That only I have quoted it here. Any doubt? Yeah. If no doubt, here in this algorithm, this is of course recursive call. There are two programs which I have used as subprograms or the procedures which I have called here. One is listing the values such as that red and all. That is not difficult because once if I give one specific feature, say like color, then first value you will note it red. You will next also red, no need. Next is green, okay, note down. Then you continue again red, no need. Like this, you are looking at what are distinct values that this particular color has in the given data set D. That is what color has in the given data set D. What is the distinct values? That can be done. You can write a small procedure. Yes, this procedure is not difficult. The procedure here, that is selecting some feature, can select a best feature. But simply I wrote select. The select feature, select best feature. This is something difficult because you have not asked me the doubt why I have started with color. I have no answer. If you don't want to start with color, okay, you can start with the shape also. No issue. And some people have tried for the same data set. You start with color, I will start with shape, another one will start with that. And even after color, what next? Should it be next is shape or next is the taste? Oh, right, several possibilities. Hence, with the different permutations, as you select the features along the path, oh, many trees may come up in the class. Each is a decision tree, no doubt. No doubt. Everyone is whoever is following this, definitely they are constructing decision tree. Hence, if you have 60 classes, 60 different trees come, okay, no issue. All 60 are answers. But the question is, some decision trees may be optimal, means containing less number of nodes and edges. Hence, definitely we feel that, oh, this is much cute, small one. Still it is serving the same purpose. It is also performing the same task. Whereas the other fellow who has drawn the large, almost all the nodes we have used and that is much bigger, it is also working same. As nation tree has more nodes and more levels, naturally, more nodes, it is taking more comparisons and hence always we prefer the optimal decision. We want to possibly smallest, that we have. Hence, how do you optimize? If you ask that fellow, no, I have simply strayed. I got so cute, I don't have any reason. Then people have started looking at, is there any clever way of selecting? Is there any scientific answer that I can give here? Oh, color is better than shape. No, taste is better than these two. Can you tell anything? That they started thinking. If that doubt won't arise, anything is okay, then you are not, the person who is contributing. You have contributed to some extent, and someone will think on this particular issue. Otherwise, no, you can take the first feature, separate it. Or at the second level, you can have F2, 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 F2. And again, the third level, F3, third level, F3, third feature, fourth level, fourth feature, fifth level, fifth feature. Like that you can go. That is also decision tree, as I said. But when you want to answer the question that it is optimal or not, that we have not so far seen. Okay. And if we want to answer that question also, at every stage, at the very beginning, I have n features like shape, color. Which one of these is best here to start with? And once I start, then at every stage again I have a mixer. I want to segregate out of the remaining, already one is used, out of the remaining n-1, which is the best. Hence this will continue. Then they started looking at it. Oh, how to answer this question? Hence our discussion is on this particular point. Then only this entire approach will be complete. Hence now, if you don't have doubt in the algorithm, I am now trying to help you in designing this particular procedure, which is helping you to select the best feature to split the given data set. Okay? Yeah. Now the question is F1 better, or F2 better, or F3 better, or Fn better? So that my D is segregates on that. Whatever you say, if F1 is better, I will start with F1. If F2 is better, I will start with F2. Hence, which one I have to put here? Which one of? F1, F2, so on, Fn. That's the question. How to answer this question? Okay. Any idea? You want to suggest something? Okay. Now you want to select one of that for what purpose? The purpose of demixing. You want to demix D. You want to demix the given mixture. Is it not? Yeah. Why you want to demix? Let's go back to the question. Why are demixing? Why you want to demix? అలా అనవసరం పంపించేసి ఆ క్లాస్లో వాళ్ళు మాట్లాడుకుంటున్నారు అక్కడ మాట్లాడి ఇక్కడ వినిపిస్తారు డిస్టర్బెన్స్ వెళ్ళిపోమని చెప్పాలి ఏం సాఫ్ట్వేర్ అప్లోడ్ చేసి ఎవరు బయట వాళ్ళు వచ్చారా ఎందుకు బిజినెస్ కాల్ వస్తుంది కదా అది Now let me come back to this students. Yes, anyway, why we want to demix? We have looked at the mixer is suffering from impurity. That impurity you want to reduce. Hence, you are demixing to reduce the impurity. This is one which I have started with in the previous session. Hence, the very purpose of demixing is only to reduce the impurity. Okay. Hence, now the question we have to reframe is, which one of these feature is better to reduce impurity. It means which feature will reduce impurity in a better way or in better quantity. It means you should know how much impurity this F1 reduces. Hence, amount of impurity reduced by F1. Amount of impurity reduced by F2. If I can calculate it, and so on, if I can calculate for each of these F1, F2, F3, amount of impurity reduced, AIR, then if I can calculate, oh, how much this, how much this, how much this, I don't know formula, let us design. Hence, if I can calculate that, based on those numerical values, whichever is large, suppose this is 7, this is 3, this is 2, this is 8. Oh, 8 is larger, then I should prefer it. Therefore, maybe, therefore I have to prefer it, since it has the largest. Is it a good idea? Hence, the best is the one which reduces maximum impurity possible. So that's why I'm calculating how much impurity is reduced because of each of these J's. J's for the 1 to n. Okay. Now, how to calculate it? Amount of impurity reduced. Hence, if someone says there is impurity in my body and I take some medicine, whether impurity reduced or not, I can count it. How I will measure? What was my impurity, total impurity originally in my body? That is impurity in this data set. Minus, after taking F1, what is leftover impurity? Leftover. How much left after taking F1? Leftover impurity after taking F1. This someone has written, it is something like there are n tablets or 5 tablets. Hence, what is the total impurity in the body? Minus leftover gives the amount of impurity. Now I am telling that suppose there are 5 tablets. On each tablet it is written this reduces 7 liters, this reduces 3 liters, this reduces 2, another one 8, another one 6. So how they know? Maybe in the lab they have experimented giving this particular tablet to a person who is having 10 liters. Leftover is 3 liters, therefore it is 7. The same person or similar person who is having 10 liters taken F2 left over with 7 liters, has 3 liters like that. Hence they administer, they give these tablets to more or less a person having this, and they might have experimented it and done this, mentioned on it. Hence the formula looks fine. Hence we have to repeat this for each j is equal to 1 to m for f1, f2, f3. What is total impurity and leftover impurity after consuming fj, after splitting on fj. Now we need two formulas. One is for this parameter and this other parameter, then this equation will become full. In 1986, Finland and his team, they have discussing this particular thing, they have contributed it. They looked at this equation looks good, but how to calculate total impurity in the given data set? Then they thought of formulating something, but suddenly they noticed that already some concept called entropy indicates this impurity. Oh, then they studied that entropy. And the entropy, you also might have studied it several courses. Even mechanical people have entropy. Information coding theory, we have entropy. Image processing, they use entropy. Computer networks, they use entropy. Particularly Shannon, when he wants to communicate some information through some media, what he has done, he has coded that information into data. Data is communicated through the media. The data is in bits. Data is in bits. Since you have studied this in computer networks, you take the information, you will code it, timing code, this, that, and you will get the bits. And those bits will communicated through some physical media. And since media is not perfect, these bits perhaps garbled with. Hence, the same thing may not be received at the other destination. So you have sent 1011 at source, you may have received 1001. Oh, you will notice the error, and that error you are correcting. Hence detecting, correcting errors, all these things happening at the next layer, the data link layer, all these things you have studied. Hence in the physical layer, he has introduced the concept of entropy. Hence in computer networks, even if you want, you can refer the books. There is a concept called Shannon's entropy, which is used at the physical layer in computer networks. But they are slightly different formula. Hence entropy is a concept, may not have same formula everywhere. Hence entropy is indicating, yes, here also there is something imperfection of this particular channel. Therefore, the noise is the reason that is changing these bits in due course of traveling through that media. Hence, the noise moves away, the signal from the signal line, it will be pulled to that particular point. Instead of lying on the signal line, it will be little far away. That signal line is supposed to be like this. But some noise, it will pull the other direction. Therefore, the one which is supposed to be here, it will be here. Hence, something like this dots will be like this. As you have more noise, then the quality is low. Hence, we want to see that signal to noise ratio. And accordingly, you might have seen something like this, minus something like this. Hence, here is the structure. Since entropy, there and here, whatever I am going to write, will have this kind. At different places, people use different. Here, I am not writing any signal to noise ratio, rather, I am going to use something called the PI. Hence, PI log PI base 2. This I is the number of classes. Since I have been telling that in the given training data set, there are number of classes covered, that is C1, C2, so on, Cm, m number of classes, m number of classes. That m I am writing here. Hence, I will have P1 for C1, that is which I say PC1, P2 is abbreviation for PC2. Hence, as we have m number of classes, we have P1, P2, Pm. Hence, this particular is the formula for the entropy. Why this? We can have discussion, but already a lot of theoretical discussion that I am putting. Let me not go into those details. Otherwise, I can start like this is touching something called the surprising factor, and that is the chances of seeing that an object. That way I can figure out, but anyway, let me not go into that. It will take again some more time. But what is this PA? The PA is probability. Means let me focus more on that. How this formula arrived is okay, that is so good and interest. But let me keep that pending and let us go ahead. What is this PA? The PA is probability. Oh, suddenly probabilities are coming. Hence, probability with which an arbitrary object belongs to a class CA. This is P. That's why for C1 there is P1, for C2 there is P2 and so on. Since you read this particular thing, probability with which an arbitrary object belongs to class C, that particular probability is represented by, is taken as PI, and that PI I am using. But how to calculate this probability? What is this really? This probability means this we will discuss. First, read that particular statement clearly. It's very important. From here, understanding it is more important for even the next approach. That's why let us spend a bit time here. Ankita Sharma, you have raised some. Ankita Sharma, do you have any doubt? Ankita Sharma raised hand.
Same to no, sir.
Okay, we can lower the hand. Okay. Okay, fine. Ankita Sharma. Yeah. So you have read this, understood what do you mean by this statement? Probability with which an orbital object belongs to class C. Can someone tell, can you calculate these probabilities? We have, many of we study at +1, +2 level. We practice problems on probabilities. Okay, some simple example which all of you can easily tell. That if a bag contains 6 apples and 10 carrots and 23 chilies, 37 tomatoes. Okay, let us think only these things are brought. Since that bag contains only this, that is 76. Total objects, out of which 6 are apples, 10 are carrots. Since apples is my C1, carrot is my C2, C3, C4. What is the probability that a randomly chosen object is an apple? That everyone can tell. Can someone respond?
72 P6.
6 C1 by 76 C1. 76 C1 is 76 only, 6 by 76. Hence, if I ask, it means, suppose your father has brought these 6 apples, 10 carrots, 23 chilies, 37 tomatoes in a bag. And if you choose some object at random, what are the chances it is an apple? 6 by 76. If you choose some, again keeping in that, if you choose some object at random, what it is, what are the chances that it is tomato? 37 by 76. 37 by 76 for PC4. Like this, you can tell what is PC2, PC3. Hence, almost all the participants are aware of this. The same thing I will quote it, slightly different, since we all have agreed. Instead of apples, carrots, chilies, which are C1, C2, C3, I will take, this is Amazon, this is something, other companies.
Flipkart.
Fine. Hence, there are 4 companies, and in your class, if you choose someone at random, What are the chances that a boy gets at Amazon? Can you tell? No, the data is insufficient. Okay, I will tell in more detail. Hence, we have something, what we have written here, arbitrary object, means we are choosing an object at random. And you are asking for that randomly chosen object, what are the chances it is C1, it is C2, it is C3. Okay, hence let me put a lengthy story. Now the people are joining into each of these NITs, Warangal, Kurukshetra. Mostly they are joining for the placements, ultimate goal. Hence they are very eager to know what are the chances that they get in some company, Flipkart, like that. Then they will ask the security fellow at the very first day, the boy and his parent, security will ask, what are the chances my boy gets in Amazon, what will get in Flipkart, company 2, company 1. The security fellow is not supposed to answer, he should tell, I don't know, I'm only security fellow. No, he will tell some answer. There's a problem with that. What he will tell is, he will say 3 by 60. For Flipkart, he will say 1 by 120. Hence, you ask, you are a student who got admission in computer science, you ask for Amazon, he will tell 3 by 60. Even if I ask, he will say 3 by 60. Whoever asks for Amazon, he is saying 3 by 60. Whoever asks for Flipkart, he is telling 1 by 120. Like this for several, each of the companies. Seeing some book and telling answer. It means, do you believe that it is correct? The person, someone said Flipkart, can you, hope you are listening, can you tell, will it be correct? Is it something believable? Is it at least statistically significant? Is it correct? Okay, let me put in more clarity. When I am choosing an object at random, suppose among these participants who are now at present around 36, if I choose someone at random, whom I will choose? When I am choosing at random, who will be get chosen? Who will be?
The probability is 1 by 30.
No, 1 by 30, that's equal, no? Fine. It means what? 1 by 30, what is the inference of that?
That one person may be any one of us.
Anyone.
Among 36, we can choose one.
Right, one probability, that is fine. I understand your value, but I am giving the meaning. Who will be get selected? Shall I, will I select, is there any chance that you will be selected? Yes.
Yes.
Since when I am choosing someone at random, any of you, I may select Sairam, I may select Kavita, I may select you, or I may select Sridhar, or I may select Sushil, I may select Minhas, I may select anyone. Hence, therefore, randomly chosen object means any object is perhaps chosen. When you are choosing randomly chosen object means it is equally likely that any object perhaps got chosen. It means there is this probability, whatever you are telling, it should be same for every person. Hence, if you all, suppose you are the students of CSC, what are the chances that any of you get in Amazon is 3 by 60? It means for each of you has the same probability of getting in Amazon. Do you agree? Do you agree? That's what the security fellow is telling. Whoever asks Amazon is saying 3 by 60. Hence, in his assumption, or someone taught him that much statistics, that whoever asks this Amazon, you tell this. What is validity behind it? It means some probability that with which that one gets in Amazon. Is it same for every student?
No.
Yeah, you are saying no for the reason for some X getting in Amazon, knowing about X getting probability of getting Amazon, chances of getting. Knowing about Y, chances of getting in Amazon is different, sir. Probability of getting Amazon by anyone, it is same. Oh, it's something far from truth. This is what there in your mind. It is there in everyone's minds in the among the participants. Therefore, difference between these two is this is what we call priori probability. Prior to know anything about Ankita Sharma, Minhas, Sairam, Kavita, Janagi, Sridhar, there is some probability which we can tell valid. That is what we call priori probability. The priori probability is same for every person before knowing anything. Hence here, what we have used here, what is this? These probabilities which we have said, and what this security fellow is telling, the probability what I am asking, these are all same. Say what we call priori probability. Priori probability. Hence, we have practiced these problems. This is indicating priori probability that we do not know. And even if we know, no sir, I know it is priori probability, this is posteriori probability, but is that priori probability what it is representing? It is representing some probability which is valid for any arbitrarily chosen object. Who is that arbitrarily chosen object? Any object perhaps got chosen when you are choosing someone at random. Therefore, you may be get selected, or the other one may be get selected when I am randomly choosing you. Then that probability is valid for you, valid for your friend, valid for every other participant in the class. Means there is some probability valid for each one of you equally. Hence, in that case, that is for arbitrarily chosen object, when you want to calculate this kind of probability, what probability I must use? Oh, it is nothing but priori probability. How to calculate priori probability? You know it. What you know? You know that how many objects belong to the C1 by total number of objects. If I ask for C2, how many objects belong to C2? How many are carrots and that? Hence, even if in the data set, I have certain objects. Object 1 is C1, object 2 is C2, object 3 is again C1, object 4 is C9, object 5 is again C1, something like this. Hence, if you look at these 3 million objects, there are probably only C1, C2, C10. Hence, in this case, what is my P1? That is PC1 is nothing but the number of objects that are labeled as C1 in the data set by total number of objects. Same thing for P2. That is, just I am asking, how many objects are labeled as C2? Count it by total number of objects. That's what you have done here. That's what you have to do here. That's what the security fellow has done. That's what I have asked you. Is that probability? Is there any probability which is same for all of you? Yes. What is that probability? Priori probability. Yes, this priori probability indicates same value valid for every person, and that is to be noted, to be used, valid in case you don't have any information, that is prior to know anything about the person. After knowing that some evidence, after knowing about that, then the chances may improve or decrease. That's a difference. Hence, this is what we call posteriori probability. After knowing posteriori. And that is also valid for you because some evidence happened. Okay, in the past batches, someone who has good in logic, good in communication, who got IIT JEE rank this much, that much range, all these things, those things happened in someone's life. They got in Amazon. Now you are a student who joined now. You also have similar things happened in your life. Therefore, you have same kind of chances of that. That's why we say conditional probability. Hence, probability, the probability with which the chances that he has got it, that's also valid to you, condition to the same evidences seen here. Same thing happened, same events happened in your life. If those events have happened in your life, there are chances that you also get in amateur. Because in the past, the people who have got those events in their lives, they got it ultimately. Hence, you are calculating probability of some future event to happen, knowing that some event already happened. That is what you are doing in conditional probability, posteriori probability. Therefore, hence one need to have a deeper understanding about these things. Fine. I hope now it is clear to you. The probability what I have written here is nothing but the priori probability, which can be calculated from the given data set, which is in the same way of this apple carrot kind, where this formula is quite simple, that Pi is the number of objects labeled as Ci by total number of objects. Okay, fine. Now I said that this, once you know all P1, P2, P3, then you can calculate the entropy, and that entropy indicates impurity. Fine. I have not derived it, but I should convince you that, oh, because I simply said, oh, impurity is governed by entropy. Oh, then you may ask, how, sir, why you are saying that entropy indicates impurity? Okay, it requires some more discussion, because they have mentioned all these things there very clearly. When I want impurity, why they have suggested entropy is the right candidate. How entropy is a concept that indicates impurity. But I will try to convince you with small thing that I said that impurity is there in the mixture. Impurity is the characteristic of the mixture. For the non-mixer, non-mixer means it is not mixer. All the objects belong to same class. All the objects belong to same class. Then impurity must be 0. Here it is non-zero. Here impurity should be 0. Is it not? As per our hence for non-mixer I should show impurity is 0. For non-mixer I should show entropy 0. Hence entropy which indicates impurity, if entropy becomes 0 for non-mixer, there is little ground on which you believe this. Is it not? Hence the non-mixer means what? All the objects belong to same class. Suppose all the objects belong to C7, 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 so on. In a data set D. Then what is P7? P7 is the number of objects labeled as C7. All the objects. Therefore, cardinality of D by cardinality of D is 1. Whereas all other PIs are zeros. Hence, there is one PI which is 1, the rest are zeros. Therefore, when you expand it, 0 plus 0 plus 0, so on, there is 1 log 1, the rest are all zeros. This log 1 is 0, therefore, the sum will become 0. This summation, this entropy, using this formula, if I calculate for non-mixer case, this entropy formula gives entropy is 0, indicating impurity is 0. Hence, for the mixer you calculate it, the impurity is non-zero. That entropy is non-zero. Some are C7, some are C6. Okay, how many this, how many that? What is P6 and what is P7? Or there are multiple 3 or 4 classes. What is P1, what is P2, what is P3? Put that, then you will get something. Okay? Hence, there is a little okay with this. Hence, you remember that for the non-mixer case, why I am not demixing? I said no, the non-mixer case, no, don't demix it. You just attach a leaf node. Why I said it? Because when you encounter non-mixer, your impurity is reduced to 0. Once impurity is reduced to 0, no ambiguity, no confusion. When there is no ambiguity in my lecture, then the knowledge is full. The information is full. Is it not? Hence, that's how we can figure out that we are calculating impurity or ambiguity or something similar words. Impurity may be appropriate for one example, ambiguity may be for another example, but they're all equivalent words which is appropriate for each case. Okay. Got it? Hence now one term is over. Now what about the next? That is leftover impurity. Leftover impurity. How to calculate leftover impurity? What is the impurity remaining after taking F1? Since once you have demixed on color, originally D, which has some impurity, it got Now this D is segregated into D1, D2, D3, D4. After F1, what is the status? You have 4 different sub-data sets. You have demixing it. Now the question is, this demixing process perhaps reduces the impurity in D when you move down. Because as you move down, impurity is getting reduced, and some path to 0 so quickly, some path it will go beyond. And ultimately, the impurity is becoming 0. You are encountering the non-mixer cases in case you have sufficient features in the data set. Ultimately, along any path, you should reach the non-mixer case in case of sufficient features. Hence now, the leftover impurity means impurity in D1, impurity in D1, plus impurity in D2, plus impurity in D3, plus impurity in D4. Hence impurity in Dk, we have to sum up these for k is equal to 1 to 4 or 4 or 5, whatever claim is on gamma, because I don't know whether it is 4 is there. 4 is for color, 5 may be for shape, maybe in another data set there may be 10 colors, and certain number, some d gamma, depend upon that particular fj. That fj, how many values it has, that many dks will be there, that many d1, d2, d gamma will be there. Hence that dks, how many dks will be there, gamma number, depends on the number of distinct values of. Fine. This, of course, this is the sum, but they have taken the weighted sum. The weighted sum means cardinality of dk by cardinality of d. That is, if 1000 values, 1000 objects are there, here 220, here it is only 54, this is 306, then they want to give 220 by 1000 weightage for impurity of D1, 54 by 1000 weightage for impurity of D2, and so on. This is the formula that we use. And here, this you can calculate. You know impurity of D, instead of D, we have only D1. Instead of D, you have D1 or D2, D3. Once you know impurity in any data set, you can calculate. Same formula, same entropy formula. Only the PIs will differ when you move from one data set to another data set. With this, we know now how to select appropriate feature. Now, any doubt? Okay. Now, with this, my discussion on giving one approach for solving the classification problem, that is by constructing decision tree, is over. Now the point is, perhaps in the introductory class on machine learning, since I have not taken the introductory class, they generally teach something that from the data we extract patterns. Because when you want to have knowledge, knowledge is interpretation of the patterns. Hence, patterns only will be extracted from the data, that you should know it. Hence, in the introductory class, we introduce these points naturally. Since perhaps you are aware that pattern means something related to similar objects, maybe collection of similar objects or something like that. And those patterns you have to extract. And yes, here in the decision tree also, when you look at from the root to once you reach some path, then all red colored and this ultimately they are all 9, C9. It means as you all the objects which are passing through this, they form a pattern. They form a pattern, they are all similar, that's why they are all given some label C9. Maybe another one, hence each path from root to a leaf node forms a pattern. And those patterns, maybe say, there is another pattern like this. Since both are sharing this particular path common, up to here it is common. Afterwards it goes like this goes like this. Hence now what we have taken? We have taken two patterns which are having something shareable part, and we have put that in a more fuzzy form, and we have got this tree structure. Hence what do you mean by this? The patterns which we have extracted, they share something like this common part. It means the patterns which we have collected, they are forming a cohesive structure, and the structure looks like a tree to you. This tree, what we have built, is called a model. Hence, model is another word which people quite frequently use. Oh, I am building model. Build a model from the data. It's quite common. Hence, what is model? Model consists of. Model is embodiment of patterns. Since the patterns so extracted, they are forming a cohesive structure that is apparent to you, that looks like a tree, and hence your decision tree is a model. Not the algorithm. The algorithm works on the data. And algorithm working on the data, it produces the patterns so extracted, formulating this model. Since model is building model means you extract patterns, that's all. Forget about whether the patterns are looks like a tree or not look like a tree, what cohesive pattern that they are forming, whether that cohesive structure is it apparent to you or not apparent to you, doesn't matter. Hence, by the meaning of building model, you are extracting patterns. That's the point. Hence, without our knowledge, the way we started from the very data set, oh, this is mixer, what is problem with the mixer, then problem with the mixer is impurity, how to reduce impurity, let us demix it. All these things ultimately helped us in building the model where there are patterns, hence unknowingly we have extracted patterns and we build the model. And that model built is used to classify this. Okay? This happens for every other algorithm. Whenever you are applying that algorithm on the data, that may build a model in the machine. Fine. Now, by the way, we got some discussion on this, which just now we said that it is conditional probability. And this conditional probability or posteriori probability, this my teacher at my +1 taught very simple trick. Oh, it's easy to remember its formula. You just make it this volta, that is G given A. And this something A you write, then the B here, A get cancelled, B something he has told me. This is the way I remember it. And someone has given interpretation also. The interpretation is what? Can someone tell what is the probability of A given B?
P of A intersection B by P of B.
Fine. Is this formula also okay?
Yes, sir.
Yeah.
But
I'm not asking the formula and everything. I'm simply asking what is the reading this probability of A given B means?
probability of A when B is already happened.
Okay. Hence, you have clarity that B is already happened. A is yet to happen. Is it not?
Yes, sir.
Yes. Hence, the same thing I told in my class when I started my career. Probability of happening A. Probability of happening A. Knowing that B is already happened. Then for that I need three values. One is what? What is this first one? Please tell. The same participant request her to please tell what is this P given A?
The same case, when A is known, we need to find the probability of B.
Yeah, here the student has asked, sir, just now you said B already happened, A not happened. When it comes to this, to calculate this, you are using probability of happening B knowing that A is already happened. Then he asks, first of all, please make it sure, sir, whether A happened or B happened, which is yet to happen. Then I know that something he has not studied statistics properly in the lower classes, or because understanding statistics something different. You cannot take in the literal spirit. But how do you infer things from what the statistics scores are telling? That is something no mind has to train ourselves, or the teachers have to train us. But the student putting me in some position, he is asking, just now you said B already happened, A is yet to happen. Now suddenly here you are saying that A is happened, B is not yet happened. Whether A happened or B happened, which is yet to happen, which is happened, you feel clear. Then can you say, no, shut up your mouth, sit down, don't know, you are not studying properly, I can't talk like that. Okay, then somehow I have designed some story. The story is, of course, I'm just replacing. It will not serve. Just I'm replacing the A with the H and B with X. It will not serve, but still I'm writing this. Hence, this is the original form. Fine, we also agree with that. Hence, H is something what we call hypothesis. Hypothesis. X is evidence, of course. Whatever it may be, these words are not much point. Hence, I started saying that, okay, hypothesis is purchasing clothes. I said that, okay, you and me will go, you are X, I am Y. Hence, if we enter into a shop, a branded shop, they will look at X, they will look at Y, this you may experience. When 2 or 3 people enter, then the sales people will look at the customers. They will assess by, oh, will this fellow purchase or not purchase? Hence, what is that? The chances that hypothesis becoming true, purchasing of cost becoming true, knowing about X. What are the purchase costs becoming true, knowing about Y? Means he is assessing whether X purchases or not. What in case of Y, what is that probability that he purchases? Hence, assume that knowing by seeing X, he is assessing Y, is assessing, but he is using these probabilities. Perhaps he is a postgraduate in statistics, that sales fellow. Hence, he is using these things. Okay, let us interpret. What is this? Probability of, this is probability of purchase by X. This is probability of purchase by Y. What is this probability of purchase by whom? Can someone answer?
X.
It is by whom?
X.
No, it is by X. If it is by X, I will write. This is by whom? Probability of H only. I have not written by X or something.
Just probability of purchasing.
Purchasing. Means what? Means what? That's what I told you in the last class. Probability of purchase by an arbitrary customer, by anyone, by any person, by any arbitrary customer, whoever enters, equal to every customer. Hence, that is what we generally say, priori probability. Hence, nothing is written here. This kind of P of X, this P of X, these are all priori probabilities. These are all conditional probabilities, posteriori probabilities. This is not, hence here, that priori probability indicates the probability with which any arbitrary customer purchases. Hence, probability of purchase by whom? This is by X, this is by Y, this is by any person. What is the probability of by any person? Any customer whom you choose randomly, whoever is entering, how to understand it, it is priori probability. Hence, by any customer means, then you have to ask the security fellow only. You go and ask the security fellow near that Raman shop. He will tell. If 1,000 customers enter, 300 customers are going out. That's what even my security fellow in NIT Warangal, he said for Amazon. He knows that if 60 people enter, join admission, take admission in CSC, 3 are going out with Amazon, 1 is going out 1 by 120 means for 2 batches, 1 fellow got selected in Flipkart. You don't know what was the capacity of that batch or this batch or you, whoever asks Amazon, he is telling 3 by 60. Prior to know about you, I don't know anything about that batch. He is seeing this for every 60. And here also telling that probability of customer, any customer, what is the probability that any customer purchases? You purchase, my purchase is different by another, any customer, which is also valid for me, valid for you. Prior to know anything about you or me, is valid for everyone. What is this? There are 1,000 customers, they enter, this security fellow is counting, daily 1,000 people enter. For every 1,300 people are going out with bags and bills. Then you will assess out of 10 people, 3 are purchasing, sir. That is generally probability value that what is telling. Yes. Since if you look at if 1,000 customers are there, since every dot is a customer, then some are purchasing, some are not purchasing, some are purchasing, some are not purchasing. How many P's are there? 300. The remaining 700 are NP, not purchase. Okay, but rather all are customers. Everything I can write CCC, but certain C's are labeled as P, certain C's are labeled as NP. The number of P's are 300, the total number of customers is 1,000. Fine. This is probability of purchase by an arbitrary customer, priori probability. Then, probability of X, knowing that purchase is happened. In whose case the purchase is happened, in whose case the purchase is happened, these 300 customers, whoever purchased, hence in those customers' case only. Now, what is the probability that X is one among them? That is what we mean. Probability of X among the purchase. Hence, knowing that purchase is happened, yes, purchase is happened in whose case? These 300 fellows. Hence, what are the chances of this X of those 300? Means, for each customer, you are noting down their features. Maybe feature something like color of the person, religion, income, and designation. Maybe these 4 influence the clothes we purchase. I am faculty, I can't wear what student wear. Hence my designation demands what kind of clothes I can do. My income, I may be interested in purchasing something like big people, but my income should permit. Hence, income influences, religion influences, color influences. Different color people prefer different color of shirts and trousers. Hence, these 4 features, hence these 4 values, having some color and some religion, some income, and some designation. I am not the only fellow on this earth having these 4 values. Suppose I am with one color C3 and some region R2 and some income range and some designation professor. This kind of C3 R2 may be for so many people. Hence, if I am X having C3 R2 and C and some range and professor, there are many other people who have visited the shop. Some may be purchased, some may be not purchased. Therefore, out of 300, what are the chances that X is? Hence, there may be some 20. Hence, 20 of these P customers who have purchased, they are equivalent to X. Is it X? Yeah, yes, X. Is it X? No, not equal to X. Why? This fellow's designation is different, my designation is different. Hence, for each P, for each customer, you try to compare the X whom you are asking. Suppose I am X. My values for the features are compared with the values of each customer who has purchased. but there are 20 customers who have purchased tally with my feature. Therefore, out of 300, 20 people like me. Therefore, the chances that I am one among them is 20 by 300. By here's probability of X. Hence, you see the difference between these two. This is among the purchase. What is the chances of X? This is not among the purchase in the entire population. Here is only purchase case. Here purchase and non-purchase, both the case. Means you take all the customers. Even this non-purchase also you have to compare. Is it X? X. Is it X? Not. Like this you count. Means out of 1,000, how many people looks like me? Maybe 60. Then if you cancel it, then if 60 people visit your shop, like people like me, 20 purchases. That's the answer. Whereas for Y this priori probability will not change. And among 300, among the purchase, how many people looks like Y? It may be 10. And by 1,000, among the entire population, entire sample 1,000, how many people looks like Y? 20. Then it is 10 by 20, half. This is 1/3. Then, if you are Y, you have more chances of purchasing than me and X. Hence, this will figure out. This is how you can tell. Once you have this understanding over the so-called Bayes theorem, if you have this understanding over the Bayes theorem, any doubt? Then the very problem of classification, which I have described in this class, that we have such objects labeled as C1, C2, C3, Cm, is a mixer, but now X is given. The question is, the features are given, but what is not given? We have to specify the class of X. This is the problem. Specify class of X. What is the answer? Answer is one of the C1, C2, Cm. This is the problem of classification. I have repeatedly told. Therefore, what is the problem? They started thinking. Decision tree is one approach. Forget about it. You may not like decision tree. Oh, lengthy discussion. Now you want to find a different approach. Oh, you started thinking on the problem. Some people who don't like decision tree, they started thinking in this way. Hence, what is the question? I am given X. X is given to me. What are the chances it is C1? Given X, what are the chances it is C2? Given X, what are the chances it is C3? Same X, I am calculating what are the chances it is C1, C2, Cm. If we can calculate each of these, whichever probability is high, suppose C7 is high, answer is C7. Oh, great. Then if you can understand at this deeper level, you will feel that, oh, Bayes theorem is just defined. Because Bayes theorem proposed in 1700, somewhere 54 or 53, 57, almost 270 years back, such an old Bayes theorem. If you understand that well, this problem of classification, we say that, oh, Bayes perhaps proposed that theorem only for this problem of classification. Such a connection you can feel and you can establish. Thereby, you can write, oh, this is simple probability of X given C1, TC1 by Tx. Since you have to calculate p-values and simplify, And here P of x given C2, PC2, P of x, note down three values and simplify it. Compare these values. When I want to compare and pick up the largest, you look at this denominator, same denominator. Why should I divide the same denominator and then compare? Therefore, I'm not changing Bayes theorem, but for my process, here I say that, oh, same denominator, I need not divide. Hence, without dividing also I can compare, because I don't want actual value. I want only compare and pick it up which probability is high. Hence, I will start with this. I need only two values. Already we know what is PC1. What is PC1? In the given data set, how many objects labeled as C1 by total number of objects? Hence, suppose the total number of objects are 1000, 300 are labeled as C1. Now here, what is this? Out of those labeled as C1, among the purchased, how many looks like X? Hence, suppose this is C1. Hence, it has some values. Whether this feature vector and this feature vector same, whether is it like X or not. Means every feature should have same value. This feature, whatever value here and here, both are same. Then only, even if one feature is different, it will not. Let's use that. 1000, here 120, here now out of 120, that is how many labeled as C2? 120. Out of the objects labeled as C2, how many looks like X? This number we have to make. This is how you calculate it. Then you will get another approach, which we call it as Bayesian classifier, where we calculate that particular P of X given C2 something on some condition that all features are independent, then it will give naive Bayesian classifier, otherwise belief networks. Like this, we can have the discussion. Hence, today, what I stressed is, it is not important always you know some package or you understand some algorithm quickly, I will code it. No, that is not. Are you theoretically strong? Are you able to understand the problem through spirit? Having have deeper understanding on the problem as well as the approach. Can you stand and teach the course with all inner details? That is what is required, particularly to have the deeper understanding that is essential to carry out the research. Hence, we are preparing the students for that. Otherwise, we are not simply teaching the skills. I'm not just training the people to use some package, this technology, that technology. No, we are designing, we are thinking. Hence, now we understood how an algorithm can be designed, how an approach can be proposed, how a problem will be looked at, what is classification problem. That's how I said. Fine, if you have any doubt, otherwise I have taken more time. I think we started a bit late also. Any doubt? Otherwise, we wind up.
Thank you, sir. Interesting session, sir.
Thank you.
Any doubt, participants? If you have, you can ask.
We thought of organizing this in person, physical initially. Sushil?
Yes, sir.
Yeah, we could not. But plan something.
Yes, we will try in April or in next month. For physical, offline mode.
But,
Thank you, sir.
And
Session
this
is very good
we
actually.
tell as ambassadors to other people so that they will come and listen to the lecture directly. Because in-person learning, teaching is slightly will have more effect than
Yes,
this.
sir. Yes, sir.
Yes, sir.
We'll keep try in next month. Otherwise, in May, once holidays will start, that time we will plan.
Yeah.
Yes, sir.
Okay, we wind up.
Okay, sir.
Right. Thank you.
Okay, sir. Thank you, sir.
Thank you very much, sir.
Yeah.
Thank you very much.
Thank you for your patient teaching, sir.
Thank
The
you,
way
sir.
you communicated was very extensive and